We're going to review solving systems, nonlinear systems. You were asked to do problems about this yesterday, but we are going to review a few problems like this. So looking at number 1, the directions here to say to solve algebraically. Please circle that. If you didn't have to solve algebraically, we could grab the calculator, we could have the answer within a few minutes, pretty easy. We wouldn't have to think too much about the process of how this works. So to do this algebraically, the first thing we need to do is we need to make sure y is by itself. So like in number 1 and number 2, I can see y is by itself, but look down to number 4. Can everybody see how y is not isolated in these two problems? All right, so we're going to do number 4 after this. Once y is by itself, I'm going to set these two quantities equal to one another. X squared subtract 2x subtract 1 equals negative 2x minus 1. And then I'm going to move everything to the side that has the x squared. So plus 2x. On the right-hand side, when I simplify, I'm left with negative 1. On the left-hand side, when I simplify, I have x squared subtract 1. Then now I'm going to try to isolate the x squared. So I'm going to add 1 to both sides. Simplify, and I have nothing left on the right and only an x squared left on the left-hand side. To solve for x, I'm going to square root both sides. This tells me I have two answers, so I'm going to put a plus or minus in front. And the square root of 0 is 0. There's no such thing as plus or minus 0. 0 is neutral. It's not positive nor negative. So x equals 0. It's important to know what you're looking for. So come back up here really quick. I have a U shape that's opening upwards, and I have a line with a negative slope. There's one of three things that are going to happen. This U shape and this line, which is the negative slope, are never ever going to touch. It means they have 0 solutions. Or it's possible they touch, but only in one spot. It's possible they touch, but only in one spot. Or it's possible they touch in 2 spots. These are your only possibilities. This quadratic formula, degree 2, and this linear equation, degree 1, will never touch in one place, or touch in 2 places. Now, where they intersect, we call those solutions. And the solution on a graph, on a Cartesian plane, is illustrated by an x and a y value. So if somebody asked you what is the solution, you describe it by thinking of it as where do they cross on the graph. And each point has an x and a y solution. So right now I've identified the x, I must always identify the corresponding y. To do that, I look up above and I go, okay, which equation looks easier to work with? I think the second one. So I write down the second equation, and wherever I see an x value, I substitute this in. Negative 2 times 0 is 0, and 0 minus 1 is negative 1. I'm going to write it as an ordered pair, 0, negative 1. Now, how can you make sure you did this right? Grab a graphing calculator and hit y equals, please. Clear off any equation that's in there. And in fact, let's go up to y. Let's go up to the windows after you've cleared off the equations. Let's make this back to our normal standard window. Once you have cleared it and you've made it your standard window, let's go back to y equals. And I'm typing in exactly what I see. X squared, subtract 2x, subtract 1, and then negative 2x, subtract 1. And my solution has already supported what I see. I have a solution of only one answer. So many students want to say, well, you have 2 answers. You have an x and y. But they represent only one solution, only one point where they cross. Now, is that correct? Does it look like they crossed at 0, negative 1? Well, we can figure that out. Please do second trace intersect. Second trace intersect. I'm going to use the arrows to go slightly off of where they appear like they intersect. First curve just represents the first equation you plugged in. Press enter. Second curve represents the second equation you plugged in. Press enter. And then now it says guess. Take the arrow, go back over the top of where they intersect, and press enter. All right. So many of us are like, well, that doesn't match up with what you have. Okay, this is scientific notation. If we move this decimal 7 places to the left, it would be like 0.0000677. So this rounds to 0. This rounds to negative 1. This confirms this answer is correct. Okay, so now for number 4, before I complete this, again, the directions say algebraically, I need to isolate the y. So I'm going to write this down. I have y plus 1 equals x squared. I need to isolate the y by subtracting a 1 in this case. y equals x squared minus 1. I'm going to box it in. That's my first equation. Now I'm going to write down the second equation. A couple different ways I could do this. There is. I'm going to choose to move the y to the left and the 7 to the right. And the reason for that is when I add y to both sides, I end up with a positive y in the left. And then when I add 7 to the opposite side, I have y equals negative x squared plus 7. Before we do anything, we need to make sure that both equations start with y equals. All right, now algebraically, let's take this quantity and set it equal to this quantity. X squared minus 1 equals negative x squared plus 7. I'm going to move the x squared to the same side, so I'm going to add x squared to both sides. And since only one variable exists, just an x right here, I want to isolate it, add 1, and then divide by 2. When you solve it, recognize you're going to have two answers. X equals plus or minus 2. This is the major mistake most students make. Most students are like x equals 2, x equals negative 2, and they stop. I just want to remind us right now, this particular problem, if we are gonna predict, I have two U shapes, one's opening up and one's opening down. And because I came up with two solutions, it's going to look something like this. They're going to cross in two places. One's opening up, one's opening down, and they're going to cross in two places. Now we need to figure out what are the y values that correspond to that. So look up to the two equations that we boxed in. Which one looks easier to work with? There's no wrong answer. I think this one does. It doesn't have a negative in front of the x. So y equals x squared minus 1. I'm going to take in a 2 and substitute in for x. 2 squared is 4. 4 minus 1 is 3. So one answer is 2, 3. I'm going to do the exact same thing now, substitute a negative into it. Negative 2 squared is 4, and 4 minus 1 is 3 as well. So negative 2 also corresponds to positive 3. Let's confirm that that is correct. Please come back up here, clear out both equations you have. I'm going to type in x squared, subtract 1. And the other equation is going to be a negative. But this is not a subtraction sign. Negative x squared plus 7. Graph them. So I have one parabola that opens up, one that opens down, and I do see two intersection points. I want to confirm that these two are correct. To do that, please do second trace intersect. Second trace intersect. And I'm going to use the arrow. I'm going to do the intersection to the left first. So I'm going to go somewhere close to it but not on top of it. Press enter. Somewhere close to it but not on top of it. Press enter. And now over the top, negative 2, 3. That does confirm this one. Check the next one. Second trace intersect. I'm holding down the arrow to the right. Somewhere close but not on top of the intersection point. Also confirms. Solve algebraically, and I want to check with the calculator. So easy right now because I have y equals for both equations. So I'm going to set these two quantities equal to one another. And then we want to move them to the same side. I always think it's easier to move the side that has the x squared. Okay, this time we have a trinomial. Remember, when you're solving this, you have a couple pathways to solve. You can always use the quadratic formula. It will always work. You can always use completing the square. You can sometimes use factoring. You can only use factoring to solve, which is the easiest way, when this is factorable. 1 times negative 8 is negative 8. What multiplies to equal negative 8 but combined to give you negative 2? Is that possible to come up with two values? Negative 4 and positive 2. Okay, remember we do opposite here. So since this is factorable, life's pretty easy. It means one answer is 4, the other answer is -2. As a reminder, most students stop here thinking they have found the answer. These are only the X answers. They need to have corresponding Y answers. So I look back up at the original problem. I choose whatever equation looks easier. I'm going to choose the bottom one. And now I'm going to substitute in 4. 2 times 4 is 8. 8 plus 11 is, help me out, 8 plus 11 is 19? Okay, so 419 I believe is one solution point. And 2 times -2 plus 11. So -4 plus 11 would be 7. So -2, 7 is your second point. Now, am I right? I don't know. Let's check. Grab your graphing calculator, go to y equals, erase the previously inputted equations, and we're going to put in what we were provided. X squared plus 3, 2x plus 11. All right. So here's one problem. Do we see both solutions? How many solutions can we see? But can we predict this eventually will hit the other side of the parabola? We need to move the y's up. Go to Windows. Let's move this up to 25 and see if I move the y maximum to 25. Is it at a height where I can now see where they intersect? It is. Okay, so at this point, I'm going to do second trace intersect. I'm going to start on the left, somewhere close to the intersection point, enter. Enter again, and over the top, -2, 7. Okay, that was one of my answers. Second trace intersect. Enter. Enter again, and over the top. And 419, that was my other point.